What is up, guys? Mr. C here. We're going to be working on lesson 8.2 today. We're going to be talking about the law of sine. So if you recall, earlier on the year before chapter 6, we covered 8.1, which was all about solving right triangles. Okay, that must have been, it's probably even before December. We started that. So we're going to be moving on to law of sines. I know you guys have done this with me in geometry, at least some of you guys. So we're going to just be going, at least tomorrow, be going in a little bit more in depth on law of sines in a couple of different cases. Let's go ahead and go over it. Already have the formula written down for you here. So we use law of sines in a triangle that isn't right. You can use it in a right triangle, but it's kind of silly because you can already use SOHCAHTOA for that. But here's how law of sines works. You take the sine of an angle, divide it by its opposite side, and that is equal to the sine of another angle divided by its opposite side. So whether you use B or C doesn't matter. These are all going to be equal to each other. And we basically solve these through cross multiplying, like it's any old proportion. So take a moment. If you need to, pause, write this down, put it in your notes. We're going to do just one example for today, and then I'll give you a couple of homework problems on Monday. And then if you're the kind of person who wants to finish it all in one day, you can do Tuesdays. Again, Mondays and Tuesdays are going to be kind of combined in one video, but I'll tell you where to take a break if you want to take a break. So I'm just going to do one example. All right, and let's go over that right now. Okay, we have this here. Directions are to solve the triangle. And when starting these, the first thing we want to do is identify a pair of opposite side and opposite angle. Like this 40 degrees goes with this 4. We have 60, but we don't have its opposite side. So if we want to find that, set up this proportion so that the sine of 40 over 4 equals the sine of 60 over b. So we do it this way. The sine of 40 over 4 equals the sine of 60 over b. And I mentioned we're just going to go ahead and cross multiply to solve these. So we have b times, remember cross multiplication, b times the sine of 40 equals 4 times the sine of 60. All right, and then just one extra step to solve there, just divide. B equals 4 times the sine of 60 over the sine of 40. So just divide, since there's multiplication here, just divide by the sine of 40. This whole thing we're going to put in our calculator here. Let's go ahead and do that. We have 4 times sine of 60. Make sure to hop outside these parentheses here. Okay. Make sure to close before we do the division. Okay. Close that parenthesis before we do division. What do we say? Divided by the sine of 40, I believe it was. Let me double check. What's up, Wes? Sine 60 over sine 40. That's what we have. Hit enter. All right, we have about 5.389. We'll say 5.39 for that one. Okay, so B is about 5.39. Okay, so that's for B. And remember, when it says solve the triangle, we need to find everything. Okay, every triangle has a total of 6 parts. It has 3 sides and 3 angles. So let's find the other 2 parts. We can't use law of sines to solve for this angle yet because we don't have its opposite side. But we do know that the sum for the interior angles of the triangle should add up to 180. If this is 40 plus 60, that's 100. We know we need another 80 for C. So C should be 80 degrees. All right. And then now we can just kind of set up very similar to how we did the last one. The sine of 40 over 4 equals the sine of 80 over C. Cross multiply. C times the sine of 40 equals the sine of 80 over 4. Not over 4, sorry, 4 times 4. And then divide by the sine of 40. And then we have our answer. We'll go to the calculator for it, but that is it. sine of 80 times 4, over the sine of 40. Calculator, help us out. I think the only thing that changed was that 80 was, or 60 is 80. Let's put in 80, let me just double check. 4 sine 80 over sine 40. That's what we have. Hit enter and we get 6.128. We'll round that to a 6.13. Okay, so C is about 6.13. So that gives us everything that we needed. We needed that little c, we needed the b here, and then also big C, we have 80 degrees. So those are my 3 parts that I needed. All right. So that was it for our first example. That's all we're going to do today for Monday. I'll give you guys check classroom for a couple of problems to try on your own. All right. And as far as the video is concerned, we're going to go ahead and pause that right now for Monday. If you want to go on, just go ahead, continue to watch, and we're going to move on, do a couple more examples. But if you want to leave that for Tuesday, you can do that as well. All right, so yeah, that's it. We'll see you guys next time. Or I'll see you still as you continue to watch. I'm not really sure how a good way to transition, but I'll just say pause now, go do your homework if you want, or continue on. So give me a moment, get set up. I'll have timestamps in the video of where we'll begin on Tuesday if you want to just go ahead and click on there. All right, so we're all set. Let's go ahead. Our next problem. So in that last case, I'll go over to it from Monday. Okay, we kind of look at this as a angle side scenario because we're given 2 angles in one side, so we'd refer to that as a angle side scenario. Now there's certain scenarios that are kind of ambiguous, okay? Like, I'll take a picture and kind of give you an example, okay? And the scenarios that those are going to be are the side angle scenarios. So we'll title this side angle ambiguous cases. Because there's some cases where if I give you a certain side and an angle, you either might be able to make only one triangle, you might be able to make no triangles with these side and angle, you might be able to make 2 different triangles. So there's really 3 different cases that we have, and I'll do my best to explain this picture here. If you don't understand the picture about what I'm about to explain, the nice thing is you're going through the problem, going over the law of sines, it'll kind of lead you to the right answer anyway. But let's go ahead and take a look at this anyway, because I think it's important that you guys understand why there's a couple different cases. So, all right, let's take a look at this case, this first one here. Okay, sometimes you just can't create a triangle with the given side lengths and angle that they give you. For example, if they give you this angle A and you have a side length, they give you this distance, sometimes that second distance just isn't long enough given this angle measure and this side length. Sometimes it's just not long enough to even make a triangle. So you might run into, when you're doing these law of sines problems, that when you do an inverse sine to get a certain angle, solve for it, you might get undefined. And if that's the case, then you're going to run into there's no triangle that you can make with the given side lengths and angle. Other times you might come up with there's only one. Okay, and then what's kind of interesting is sometimes you might come up with there's 2. So if they give you a certain angle and side length, you can see here this distance A and this distance A are the same, but if I'm looking at this third side that you solve for, sometimes it could be shorter, sometimes it could be longer. So we'll go over how to solve for both of those, because there's some cases where you'll have 2 triangles. So I'll tell you guys how to figure that out as we're going through the problem when that will happen. Yeah, so let's go ahead and try an example. We'll do 2 today, and then we will call it. So let's do our first one. Okay, so let's do an SSA triangle. Let's do one with no solution. What is that going to look like? Okay, so let's look at if A is 2, C is 1, and capital C, angle C is 50 degrees. So they won't always give us a picture. So they're just going to give you, okay, what if one of your side lengths was 2, one of your side lengths was 1, and the angle opposite of the side length of 1 is 50. So we can draw that out, and this is probably by no means accurate because, well, obviously it's not going to be accurate because I just told you there's no solution to this. But let's say we have this 50, this is 1. If this is 2 here, that means this is angle A. We have B, and we have B. So this is probably, again, nowhere accurate to what the triangle, or the lack thereof, is going to look like, but it does help me set up the law of sines as far as knowing what's opposite of what. Okay, so let's go ahead and try to solve for one of these angles, like angle A, for instance. I do know 50 goes with 1, so I can use that, and then the 2 goes with angle A. So if I'm trying to solve for that, I could say the sine of 50 over 1 equals the sine of A over 2. All right, sine 50 over 1 equals sine A over 2. Cross multiplying by 1 is just going to give me a sine A. So we have sine of A equals the sine of 50 times 2. All right, and if we're trying to solve for A, if you recall, we're going to inverse sine this whole thing here. Inverse sine the sine 50 of 2 is going to give me what that angle is. So A is equal to the inverse sine of sine 50 times 2. So let's see what happens when we put that in. So we do, okay, inverse sine of the sine of 50 times 2. Inverse sine of the sine of 50 times 2. Hit enter. What is this? 90 plus 56.756. Notice that I there. So this is a complex. Basically what it's saying is that this is, I don't know how your calculators are going to output it. Probably say undefined or error or something like that. This one gives me a weird imaginary number, letting me know that there's no solution to this one. So there is no angle. There is no angle A in which that I can have a sine 50 or an angle of 50, a side length of 1 here, a side length of 2 here. There's no triangle I can use to fit this description. So at this point, if you're doing homework, you can just say no such triangle. It's basically saying the same thing as no solution. Okay, there isn't a triangle that I can build that they're describing. So that's what a case like no triangle looks like. It's pretty simple because you'll run into an error and you'll know right away that, okay, this must not exist. All right, so that's no solution. Let's take a look if I have 2 solutions. So SSA with 2 triangles. All right, and here's what is given. We have A is 6, B is 8, and A is 35 degrees. Okay. Let's go ahead and start with law of sines. We'll do the sine of big A, angle A, over A, and we'll solve for angle B. So the sine, whoops, that's weird. Sine of 35 over 6 equals the sine of B over 8. Let's go ahead and cross multiply. 8 times the sine of 35 equals 6 times the sine of B. One more step. Divide. 8 times the sine of 35. Divide that by 6 equals sine of B. So we got sine of B by itself. Remember, if we're trying to solve for an angle, you always have to inverse. So we should have the inverse sine of this whole thing. 8 times sine 35 over 6. This is my angle B. So let's go ahead and figure out what that is. All right. So what did I say it was? It was the inverse sine of 8 times sine 35 divided by, what's that, a 6? Okay, inverse sine of 8 times sine 35 over 6. Enter. I get a 49.88. We'll round that to 49.9 degrees. Okay, 49.9 degrees. Now, the issue is there's another angle that has the same sine. Okay, there's another angle that has the same sine. So let me try to explain this as best I can. Let's go ahead and look at the unit circle. Okay, so what did we say? It was about 49 degrees. That's about right here on my unit circle. Okay, so is there another angle that has the same y-coordinate? There is. If I go across here, there's another angle that has the same y-coordinate. And the way you find that is just do 180 minus this angle. Okay, that's going to give me, if I take 180 minus this distance, okay, that's going to put me exactly where I need to be. So what's 180 minus 49.9? Okay, it's 130.1. Okay, 130.1. Right. Now this doesn't happen all the time. When does this happen? Well, I shouldn't say that. This happens all the time. If you have an angle over here in the first quadrant, there's another angle in the second quadrant that has the same sine ratio. What I mean by this doesn't happen all the time is it doesn't always produce two triangles. So if I'm going back here, whoops, I'm going back, where are the notes? Here we go. If I'm going back to this, B could be 49.9 or B could be 130.1. Now, how do I know if I can use two triangles or not? Or sorry, two angles or not? Well, let's go ahead and compare this angle with the last one that we were given, 35. Okay. Sometimes if the angle that we're given, the first one, if this is small enough to where when we get this other angle here, if I take this angle and add this angle to it, if it's still less than 180, that means I have enough room for the possibility of two different triangles. Okay? And I'll say that one more time because this is basically how you check, okay, to see if you can have two triangles or not. All right? Get this other angle here, the 130, by doing 180 minus this angle here. Okay, then check. All right, this other angle, like for instance, this 130. If I add that to my original angle that was given A, do I still have room for a third angle? Meaning, does this A plus this B add up to be less than 180? And in this case, it does. If I add 130.1 plus 35, 130.1 plus 35 should give me a 165.1. And what that's going to tell me, since this is less than 180, I do have room for a second triangle. Okay? Again, add those two, check. I do have room for a second triangle. Now, if this A had been something like, I don't know, 70 degrees, you gave me that, right? This no longer works because if I do 130 plus 70, that's going to be greater than 80. I don't have room to make a second triangle. There isn't enough to have a third angle, if that makes sense. So change that back to a 35. Again, the process, I'll say it one more time. Once you do 180 minus the first angle you find, you get that angle. Add this to your original that you started with. If that's less than 180, okay, you will have a second triangle that you can do. So basically, we need to proceed with both of these options, okay, when we're looking for the other C's, okay. So let's go ahead and separate our two cases, and I know this is kind of a long problem, but hang with me. Okay, so we could have B is equal to, sorry, not, yes, that is big B, 49.9. Okay, and we'll also have the case where B is equal to 130.1. Okay, so we're going to proceed with two separate cases. So if B is 49.9, let's go ahead and solve for angle C. If B is 49.9, that means if we take 180 and subtract these two, 180 subtract 35, subtract 49.9, I get a 95.1. Okay, so C could be 95.1, or C could be 180 minus 130.1 minus 35, or it could be 14.9, okay, depending on how we draw a triangle. Say 14.9. Okay. So then we need to proceed. What would little c be then here, and then what would little c be then here? Okay. So let's go ahead and do law of sines again. The sine of 49.9 over, what was it? B was 8 equals the sine of 95.1 over C. Cross multiply. C times the sine 49.9 equals 8 times the sine of 95.1. Okay, and then just divide. C will equal 8 times the sine 95.1 over sine 49.9. And I know I'm about done with this problem, so I know you guys are, if you're even still watching, way done with it too. But we're almost there. So let's multiply these through. 8 times the sine 95.1, was it? 95.1 divided by the sine 49.9. Okay, little c could be 10.42. We'll say 10.42. All right, could have a 10.42. Or c could be, let's set up law of sines one more time. Sine of 130.1 over 8 equals the sine of 14.9 over C. C times the sine of 130.1 equals 8 times the sine of 14.9. One more step, c equals 8 times the sine of 14.9 over 1, sine of 130.1, and thank goodness we are almost done. All right, that was 8 times the sine of 14.9. Divide that by the sine of 130.1. And I get a 2.69. Whew. So those are my two different cases. Given these three side lengths, okay, I could have these two angles with that third side length, or I could have these two angles with that third side length. And again, just to give you an idea of what that looks like, going back to this picture, it would look something like this. Okay, it looks something like this. So you could have a shorter angle, or that angle could have been longer, right here, okay, which would produce either a shorter side or a longer side, okay. I'll go ahead and look online, see if I can find something that's maybe a little bit better, like some kind of picture that would explain this better. Hopefully I did all right. It's kind of difficult to just kind of talk over the screen to explain that, but that is it for Tuesday's lesson, okay. Go back here. So go ahead, leave me any comments. I'm sure I'll get some questions and stuff about how to do these ones. Check on Google Classroom for the homework. And again, either leave me a comment in Classroom, YouTube, email, whatever you got to do to get a hold of me and ask me whatever you need to. So miss you guys. We'll see you next time. Peace.